Okay, as requested, this is a quick little refresher on how we factor out perfect squares, or imperfect squares. So, as I've mentioned in class and as is up on the wall, between 1 and 225 there are 15 perfect squares. 1, 4, 9, 16, 25, 36, etc., all the way down to 15 squared, which is going to give me 225. Now, all the other numbers in between 1 and 225 that aren't on that list are imperfect squares. But that doesn't mean we have to leave them as these big, bulky numbers. We can actually use our knowledge of factoring imperfect squares to make them a bit more palpable, a bit more usable, and a bit more visually friendly. So, let's take 4 times 9, just as an instance. Now, I know that 4 times 9 equals 36. I'm multiplying two perfect squares together, so I'm going to get another perfect square. Square root of 36 equals 6, right? So, now, watch how I'm going to break down 36. And the reason I'm starting with this is because I know that 36 is a perfect square. So I know that whatever answer I get, if I do this problem a little bit differently, needs to be 6. Because the square root of 36 is 6. Okay, it's plus or minus 6. We're just going to use the positive version right now for ease. Okay. So, if I break down 36 into two factors, I get 4 times 9. Okay, remember that's kind of where we start over here, 4 times 9. And I can actually break that down to the square root of 4 times the square root of 9. You guys should remember this from algebra. And that gives me 3 times 2, because the square root of 4 is 2, square root of 9 is 3. I don't know why I switched them, just did. 3 times 2 equals 6. That checks out. So, why is this important? Well, what if we have a number like the square root of 12? Square root of 12, so we have the square root of 9, that's 3 squared. We have the square root of 16, that's 4 squared. So that means that the square roots of 10, the square roots of 11, the square roots of 12, the square roots of 13, the square roots of 14, and the square roots of 15 are all imperfect squares. They're irrational numbers. But that doesn't have to mean we have to leave it like that. I can break this down into the square root of 4 times 3. That gives me the square root of 4 times the square root of 3, or 2 radical 3. Okay, why this is important? Because now I can divide that by 2. I can simplify that even more now that I have a whole number on the outside. And watch, even if I put this into a calculator, it works. So if I hit radical 12, or the square root of 12, on my calculator, I'm going to get 3.464. Now, 2 on my calculator is 2. That's a shocker. And the square root of 3 is 1.732, etc., etc. So if I hit the square root of 3 times 2 on my calculator, guess what I get? 3.464. It's the same number. It's the same thing. So you can do that to check your work just to make sure you have the same thing. But again, unless specifically asked, I want you to keep it in its radical form. It is the most correct answer. Okay. So next, let's look at the square root of 72. That's going to give me 9 times 8. Now, one of those is a perfect square. The other one isn't. But the other one actually has another perfect square hidden in it. So, we can go 9 times 4 times 2. 9, square root of 9 times the square root of 4 times the square root of 2. So now we have 2 perfect squares right there. So we're going to go 3 times 2 times the square root of 2, which gives us 6 radical 2. Now notice that that actually works in case I had gone the square root of 72, and in breaking that down, I had realized that that's the square root of 36 times 2. Square root of 36 times the square root of 2 would give me the exact same answer. Okay? So look at the square root of 108. We're just running through multiple problems here. Now, what I'm going to do here is I'm going to break everything down to prime numbers. I'm just going to show you another way of doing this. We're going to get the square root of 108 is the square root of 2 times 54. That's going to give me the square, and then I'm going to break 54 down to 2 times 27. Then I'm going to break 27 down to 3 times 9. Then I'm going to break 9 down to 3 times 3. So notice I have 2 2s and 3 2s, or 3 3s. So what this allows me to do, now keep in mind, if I ever have the square root of 2 times 2, square root of 3 times 3, square root of 4 times 4, square root of 100 times 100, square root of 17 times 17, that by the nature of these, I'm going to get that number, because keep in mind what the square root says is this is a number times itself, right? So if we have 2 of the same number under the radical sign, we can actually move 1 out. So we have 2 2s, 2 3s. So we can take 1 2 out and 1 3 out and get 6 radical 3. Okay? So that's going to be 6 radical 3. Okay? Now keep in mind, if that didn't make sense to you, if you're over here and this was kind of making sense to you, and then we went over here and that's not, feel free to simply ignore all of this and just focus on this right here. You will get the same answers. I want you to do whatever you feel most comfortable with. So, last one, 108. We just did this, but I just want to show you we can do it a little bit differently. 2 times 54. That's 2 times 9 times 6. We can combine those 6 and that 2 and get 12. 9 times 4 times 3. And check it out, we still get 6 radical 3. Lots of different ways to skin this cat. It requires your factoring skills. It requires you to be able to break down a number and understand what fundamentally it is that a radical is asking you to do. If you have further questions, you know where I am, where I work, what my email is. Feel free to ask me. Have a wonderful evening, children. I will see you all tomorrow.